So let me start today's lectures. Okay. So as usual, please log in into the WebCT system. Today's content is A1-C- PDF. Okay, everybody, please open. Oh, today's topic is structure type. Can you imagine structure type? No. So actual content of today's lecture as shown here. First, I will introduce the structure type and how to declare the structure type and how to declare of structure type variables, and so on. Okay, so in today's lecture, I introduce several examples. Okay, using the structure type data. So you already know what kind of data type there are in C programming languages. For example, integer type, floating point type, character type, and so on. So however, in your program, sometimes you have to treat the more complicated data. So for example, your personal data. So usually such a data includes name, birthday, age, address, physical address, and phone number, and so on. So if you want to treat this kind of data, you have to use the structure type data. Okay? So first of all, I'd like to introduce how to declare the structure type. Okay? So this is the general form. Struct, I mean the structure. This is a special symbol for declare the structure type. The next term is the structure name. And using brackets, inside bracket you have to put several data. So the pair of the data type and the variable name. So such a data variables are usually called the member variables. Okay? So for example, if you declare personal information, such data include the address name as I explained. So such name and address are treated as member variables. Okay? So I introduce a very simple structure type, point data. So usually point data consists of two values, x-axis and y-axis. Okay, especially for 2D graphics. So using struct symbols, you can define the point structure type. Okay, in this case, the point is the structure name, and this structure data consists of the two values. So x and y are treated as member variables of point data. Those data are declared as an integer type. Okay, so usually, especially for the computer graphics, the x and the y coordinates are treated as an integer type. So if you, as shown here, if structure data type for points is declared, you can define the variable A, B, C for structure type. like this. So if you don't declare the structure point, you can directly declare the structure type as point data. In this case, you don't need the structure name. Only the member variables you can define. Okay. So these three declarations are completely same. However, this is somehow different. In this case, you can specify the initial values. Okay, 320 and 200 are treated as the initial value of member variable x and y of point data A. Okay. So once you declare the structure type data, sometimes you have to access the actual data, actual value of such variables, member variables. Okay. So this is a general form. First term, this part is a structure name, and the second part is a member variable name. Okay. So dot is a separators. Okay. So if we specify the point data, point structure type, like this or like this. This case is PT is a variable for structure type data of point. Okay, and the initial value that means the point member variable x of point data is 320, and member variable y of point data is 200. Okay, so using printf functions, you can display the actual value of these member variables of point data. Okay, so using this function, you can see on the computer graphics these values. Okay, so there are two types data: the actual data, instance data, and the pointer data. Okay, so of course, even the structured data type, you can define the pointer type data for that. Okay, so usually using asterisk, if you put the front of the variable name, put the asterisk character front of the variable name, this variable treated as a pointer type. Okay, so if you define, for example, this point data type and initializations. Okay, so already PT variable are defined as a structure type of points. Okay, so using the mark, you can obtain the actual address of these variables. So such address can be stored as a pointer data type value. You understand? Okay. So if you specify the pointer data type for structured point, in this case PT2 is variable for that. Of course, using printf function, you can also display the member variables of these data. So however, PT2 is not instance data. This is a pointer type of data. So somehow the specification is different. Okay? So point data, this case is a PT is actual variables. This case PT2 is treated as a pointer type. So if you want to access the actual value of the member variables, you have to specify like this. Hyphen and smaller. Okay? So usually treat it as arrow. Okay? arrow. Yeah. So, can you understand? Okay. So, of course, as shown here, you can use a nesting declaration of structure type. So, once you define the structure type or point, this data type is treated as other type data, like integer or floating point, almost same. So this case is using the two-point data. Usually you can define the rectangle by specifying the 2 points, right top position and left top position and right bottom positions. Okay? So using the point data, 2-point data as member variables of the rectangle, you can define the structure type of new structure type of rectangle. Okay? So this case is rect means the structure type name. Okay? This type has two member variables, PT1 and PT2. These are treated as also structure type of point. Okay? So point 1 and point 2 also has a member variable x and y. Okay? So this is actual definition, specification for defining these rectangles. So this case, box is a variable name for rectangle data type. Okay? So using point .pt1.x, you can access or substitute any value into the corresponding member variables. Okay? This means the box is this rectangle, and pt1 is corresponds to this point. pt2 corresponds to these points. Okay? So point has two variable member variable x and y. So this case is x is 10 and y become a 10. Also, point 2 is also has up two member variable x and 1. This case is those values are 100, 100. Okay? So this specification you can define these rectangles 10, 10 and 1, 10, 10 and 100, 100. Okay? So structure data type also actual values are stored in the physical memory of your computer system. So for example, for the case of the point data type, as I explained, this data type has two member variables x and y, and those member variables are treated as integer type. Okay? So if you declare the point variable, pt variables, pt the variable name, and this variable has a point data type. Okay, so pt has two member variables x and y. So if you define this struct point pt, in your computers, actually x and y, two integer type data prepares for this pt variables. Okay. So using the .x and .y, you can substitute any values. Okay. So also you can treat array data for any structured data type. Okay. So this case directly defines the structure type of point by specifying directly specifying member value of x and y. Okay. So this is the general form for array data declarations. Okay, the size is 10. Okay. So if you specify the structure data type for points using this form, you can also define the variables a as array data. Its size is 10. Okay. So also using this form, you can define the initial values. Okay. So not so difficult. So can you understand? Okay. So from here, I'd like to introduce some actual example program using structured data type. So the functionality of the program is already almost the same. I already introduced. So first example it can calculate the total sales for January, February, March of 2 branches. Okay. So there are 2 branches, West branch and East branch. So January, February, March sales. Okay. So January, February, March sales. And this program have to calculate the total sales for each month. Okay. So there are 3 branches. In fact, 2 branches and 1 company. Okay. So first you have to define the structure of data like this. Company name, this case is a branch name, and January sales and February sales, March sales. Okay. So these 4 lines are declaration for that data structure. Okay. And actually there are 3 data. You need 3 data: company, 1 company, and 2 branch. Okay. These are variable name. Okay. So these variables has a name sales data type. Actual definition like this. Okay. And this program has to calculate the total sales for each month. Okay. So month is treated as the pointer of January, February, March. And B, there are 2 branches. So West branch or East branch. Specify using B. Okay. So first you have to set the initial values. String copy functions, you can set the branch name and the company name. Okay. And also you can initialize the sales for 0 means January. 0 means January, February, March. So this corresponds to the branch the west branch and the one treated as the east branch. This value are treated as a month, January, February, March. Okay, so this means west branch's January sales is 100,000. Okay. So this is the main part for calculating the total sales for each month of 2 branches. Okay. So first you specify the month using the month variable 012, 012. Okay. And using B variable B, you can specify the branch, west branch or east branch. So actual calculation part is only this line, okay? And using these lines, you can see the result of the calculation. So, do you have any question? No? So second program, exam program using structure type is calculates the deviation of some student examination score. Okay. So in this case, you have to define the students. The student has a student name and the student score. Okay. So as a member variable, you have to specify the name and the score for student data. Okay. So like this. So name underscore score mean structure type name. Okay. So this structure consists of 2 member variables, name and scores. Using array of character type data, you can treat the string data for other student name. Okay, the maximum size is 5. So actually, you can use maximally 4 characters as a name. So as I already explained, the last place the data should be stop symbols. Okay. And the score. So this is the actual declaration for data type, data variables. Each size is as array data. Each size is 10. Okay. So structure type name score. So you already checked the how to calculate the deviation score. You can calculate deviation score for each student. Variable I is treated as indicator for specify the students. Okay, using this equation, you can calculate deviations. So for calculate this equation, you have to also calculate average and standard deviations. So each value is also calculated using these expressions. Okay. This is the actual program. So in this program, you can treat the maximum 10 students data. Okay. So large N is treated as such numbers. Maximum student number. Maximum number of students 10. And first you have to declare the structure type name underscore score. Each member variable name and score as I explained. And using this line, you can define this structure type data as arrays okay, such a variable name with data. So in this case, you cannot specify directly. You don't need to specify directly the size of the array. So, however, other initial data, you can implicitly specify the maximum size because these data set there are 10 set data. Okay. And also, there are several variables you have to define. Okay, so using this part, you can calculate the total scores, and by dividing by n, you can calculate the average. And also, this part, you can calculate the inside of the square for standard deviation expression. Okay, and by dividing by n and using square root functions, you can calculate the standard deviations. This case is sigma variable are treated as standard deviation. Okay, and standard deviation and average, you can calculate the deviation for each student by changing the pointer variable I. Okay. So, do you have any question? No? No? Okay. So, third program displays the bar chart of n integer data. So, this case is data is almost the same as the previous examples. Okay. So, student name and date score. So, this structure definition is completely the same. Okay. And so the maximum number of students that in this case is 100. Okay, so D is treated as the array data of this data structure. The maximum size is 100. So first, using printf function, the program output the string the number of data less than 100. Then you can enter any integer values for maximum for the actual number of students. For example, 10. Then program also displays this string, enter 10 integer data one by one. Okay. Then using this for loop, you can enter each student's name and score one by one. Okay. So after entering the complete data, this program also displays the bar chart using asterisk characters. Already you can check such a program. Okay. However, this case is the first leftmost column is treated as a username. Okay. So actually, this program displays like this. Okay, using this part, these lines, this program display the bar chart for each student. Okay. So, okay? No question? So, fourth program is a sorting program. So, the sorting algorithm is almost the same as I already explained, the bubble sort. Okay? So, this part is a such algorithm. So data is a student data. Completely same the previous data, student name and the student scores. Using according to the student scores, this program will change the order of the list. Okay. Into the descending order. So finally, you can see the descending ordered list of student name and score. Okay, using this part. So this is the end of the today's content. Okay. So as shown here, please try to make 4 example program I already introduced, and please make an execution file and to check the behavior of such program. Okay, so please try the remaining time.